Okay, differential equations, part two. Just wanted to go over some really quick stuff. As stupid as it sounds, differential equation, an equation that has a derivative in it. So, what is a differential equation? How would you know one to see one? Second off, what do they do? Well, they're often used to solve problems that do with rate of change or with varying times. The third thing I think that you should know as a formality is that there are three basic forms. The first form is the derivative form. The derivative form, which would look like this, which is like y double prime plus y prime is equal to 0. The other one is the differential form. Differential form. I'm going to get through this quickly, but just so you know the forms, so you know if you're seeing it or not, would be like this. Second derivative of y in terms of x plus dy dx, again, is equal to 0. And the last form is called the differential operator form, or the operator form. And it would look, it's done in capital letters. Okay? All having the same meaning. So just thought you should know these things a little bit. So there's that gift to you. Hope it's helpful. Now, if you don't mind, I just want to get to a couple problems. Quickly. As a matter of fact, there's a problem that's I've seen it 1,000 times, but it goes through a lot of stuff and is really helpful. So if you don't mind, I'm going to use this really simple example that has a particular solution, and it's a separable differential equation, and it's not too complicated. So I'm just going to start with this. dy dx is equal to y over x. And I guess as a general rule, when you see something in this form, the first thing you usually do to take it as a differential is to multiply both sides by dx. But what I want to do is separate this into y's and x's. So if you don't mind, I'm just going to do it this way. So I'm going to have, here I'm going to have y dy is equal to x dx. From there, I'm going to go ahead and start to say I'm going to take the integral of this. So I'm going to take the integral of y. I'm going to integrate both sides. So y dy is equal to the indefinite integral of x dx. So if I was writing on the AP exam and I was making sure that I was trying to be careful that I was writing in terms of calculus, this is how I would make my answer look. And then I would go ahead and start to integrate that. And this would be y squared over 2 is equal to x squared over 2. And I can hear somebody out there saying, what about c? So, okay, c. And because I'm going to have c on both sides, I'll call this c1. And I'll call this plus c2. And then what I'm going to do is I'm going to move all of the variables to one side and all the constants to the other. So that would give me y squared over 2 minus x squared over 2 is equal to c sub 1 minus c sub 2. And some math here. Remember, these are just constants, so we're not too worried about these. But if we're just going to do the math, c1 minus c2 is equal to c3, or just c if you want, c. And I guess, you know what else you could do here is you could just multiply this whole thing by 2. And if you can see what I'm doing here, I'm just using this grounding technique to set the denominators to 1. So that would give me y squared minus x squared is equal to 2c. Right? And 2 times c is just c. Remember, this is going to change one constant for the next one, so I'm going to go ahead and do that. And here I'm going to go ahead and take my particular solution. And if you remember at the beginning of the video, did I set it? X is 1 at y is 1, so that's the point, 1, 1. So I'm going to go ahead and substitute here and say that 1 squared minus 1 squared is equal to 0. So that's my particular solution here. You have to be careful here because you can see why a person might do this. They might say, well, if you look at it, then y squared would be the same as x squared, and that may be true. But remember, just look at this for a second. because what I'm afraid of is that somebody's going to take the square root of both sides to get rid of these squares. And that would suggest that x has to be equal to y. But that's just fundamentally not true. And if you think about why that's true, let's say that y was equal to negative 2 and x was equal to 2. Well, 2 and negative 2 are not the same number, but negative 2 squared is 4, and 2 squared is also 4. So I would leave it in this form right here, or maybe this form here, but I would be very careful to think my way through that. When you have squares, you have to really worry about erroneous solutions, and erroneous solutions include the solutions that are left out. So I hope this video was really helpful for you. I'd love to hear your comments, and if you're not already subscribed, would you please subscribe? Thanks.